All right, guys, in this video, we're going to talk about some asymptotes. So first things first, I hope you actually went through and tried to do some of these yourself. If not, please pause this video and give at least number one a try. The second thing that I'm going to do is I'm going to pull up the guidelines paper that I handed out yesterday. And it tells us how to graph rational functions. So the first step, it says, whenever we are given a rational function, we want to make sure step one is to factor both the numerator and the denominator so that it can give us some more detail about our graphs. So when we look at these examples, first of all, number one and number two, we're not going to be able to factor those, but we can definitely see in number three, we're going to be able to factor the numerator into two factors our factors are going to multiply to -6 and add up to -1. So it's going to be -3 and 2, and x plus 1 is still going to be on the bottom. So we factored. There are no common factors in the numerator and the denominator, so technically factoring didn't really help us in this situation, but we can see that there are no holes. Okay, so two things that we want to find are the vertical asymptotes and the end behavior asymptotes. So let's go ahead and look at what it says for our end behavior asymptotes and our vertical asymptotes. It says over here, step number 4, since that's listed first, let's go ahead and do that. So to determine the vertical asymptotes, we find the zeros of the denominator after we remove common factors. So again, we said there are no common factors. There was nothing we can cancel out in the numerator and the denominator in any of these problems. So we are just going to look for the zeros of the denominator. So vertical asymptotes have to do with the denominator. So here my denominator has x plus 3. And we know from unit 1 that we don't want 0 to be in the denominator. So my vertical asymptote is going to be the number that makes that denominator 0. So in this case, my vertical asymptote is going to be -3. Because if it was -3 and I plug that into the denominator, you would get 0 in the denominator. So that's the vertical asymptote. So same thing with number 2. We take that denominator, we set it equal to 0, subtract 3 from both sides, divide both sides by 4. So we get our vertical asymptote to be -3/4, making this last one, again, super straightforward, set that denominator equal to 0. So we get -3/4 and -1 for these last two problems. So I'm going to go ahead and draw those dotted lines. Again, kind of just approximating where that -3/4 is, but that's our vertical asymptote. Okay. Now we have these end behavior asymptotes. So our end behavior asymptotes, that's step number 2 right here, has to do with the degree of the numerator and the degree of the denominator. Okay, and there are 3 situations, right? The denominator degree could either be bigger, equal, or less than the degree of the numerator, right? And depending on which situation, that tells you what the end behavior asymptote is going to be. Okay, so if we look at number 1, the degree of the numerator is technically 0 because there's no x there. It's technically x to the 0 power. So our degree of our denominator is going to be 1, right? This is x to the first power here. So here our numerator is going to be less than our denominator. So if we go back to that guidelines, when the numerator is less than the denominator, that's this one, right? Or the denominator is bigger, easy peasy, our horizontal asymptote is just y equals 0. There's no work required. You just have to know that our equation is y equals 0. So I'm going to have a horizontal end behavior asymptote there at y equals 0. If we look at number 2, again, the degrees now are equal. Both of them are going to be a degree of 1, right? So my numerator degree is going to be equal to my denominator degree. So if we go back to those guidelines, when the degrees are equal, our end behavior asymptote is the ratio of the leading coefficients. So we talked a lot about leading coefficients in our last unit. So our leading coefficients are the number that's in front of the variable with the highest degree in both the numerator and the denominator. So in this case, those two numbers are 10 and 4. So you can leave it like that. You can simplify to 5/2 or 2.5. Any of those answers are going to be acceptable for this problem. And then last but not least, for number 3, we can see the degree of the numerator is 2, the degree of the denominator is 1. So in this one, our numerator is bigger than our denominator. Okay, so that leaves our last situation. When the numerator is bigger than the denominator, it's going to be an oblique asymptote or a slant asymptote or a SLASI. All of those things are the same thing. And the way that we're going to find that is we are going to divide using synthetic division. So we're literally going to take this division problem, right? This is x squared minus x minus 6 divided by x plus 1. And just like we did in our last unit, we're going to take the coefficients of the numerator. So 1x squared minus 1x minus 6. And we're going to divide it by the 0 of the denominator, meaning the vertical asymptote, meaning that x equals -1. And we're going to go ahead and go through synthetic division, drop down the 1, multiply, add, multiply, add, and we get our remainder here to be -4. Okay. In this problem, we do not care about that remainder at all. Remember, this is our remainder, this is our constant, and then we have our x. Okay, so our answer to the end behavior asymptote is whatever we get after we divide, again, ignoring that remainder. So we get y to equal 1x minus 2, or if you just write x minus 2, that's fine as well. And then we got to remember how to graph this, throw back to algebra 1, that slope-intercept form. My y-intercept is -2, and we're going up 1/1, right? Or we can go down 1/1. So our slant asymptote would look something like that. Okay. So that's all the things that we can figure out algebraically. We can go through and we can find some key features as well, but this was focusing on asymptotes. So I'm just going to go ahead and sketch or go to Desmos to graph these. So I have the first one already typed in. It's going to help us get our key features. So again, we're going to have a graph right here. You can look and see if I typed in my, my end behavior, or my slant, oh my goodness, my vertical asymptote that we discovered. You could see it right there. It's never going to cross that, that vertical asymptote there. So we are checking our answer. We know that we did that correctly. So I'm just going to go ahead and draw in our lovely graph like that. We can do the same thing with the second equation. Again, typing that in, you can see there our vertical asymptote is accurate at that negative, what did we say? It was -3/4, right? So again, typing that in, you could see that works. And we can also type in that horizontal asymptote at that 2.5. Again, you can see at the end of my graph, I'm going to get really close to that new line that just popped up, but it's never going to actually cross it. So again, we can just kind of sketch in our graph here. We're not super worried about too many accurate points there. And then last but not least, our last graph is going to look something like this. Okay, here you could see our SLASI, y equals x minus 2. Okay, again, at the end of my graph, I'm going to get closer and closer and closer to that, but it's never going to cross it. Okay, so you can kind of check your work using your calculators there, and then make sure you're sketching in your accurate graph to go along, never crossing those asymptotes, but getting really close to it. And there are our end behavior asymptotes and vertical asymptotes.